Hello and welcome to this lecture. My name is Mumshad Manambet and we are learning Kubernetes for beginners. In this lecture, we will discuss about networking in Kubernetes. Let us look at the very basics of networking in Kubernetes. We will start with a single node Kubernetes cluster. The node has an IP address, say it is 192.168.1.2 in this case. This is the IP address we use to access the Kubernetes node, SSH into it, etc. On a side note, remember if you're using a Minikube setup, then I'm talking about the IP address of the Minikube virtual machine inside your hypervisor. Your laptop may be having a different IP, like 192.168.1.10, so it's important to understand how your VMs are set up. So on the single node Kubernetes cluster, we have created a single pod. As you know, a pod hosts a container. Unlike in the Docker world, where an IP address is always assigned to a Docker container, in the Kubernetes world, the IP address is assigned to a pod. Each pod in the Kubernetes gets its own internal IP address. In this case, it's in the range 10.244 series and the IP assigned to the pod is 10.244.0.2. So how is it getting this IP address? When Kubernetes is initially configured, we create an internal private network with the address 10.244.0.0 and all the pods are attached to it. When you deploy multiple pods, they all get a separate IP assigned from this network. The pods can communicate to each other through this IP, but accessing the other pods using this internal IP address may not be a good idea, as it's subject to change when pods are recreated. We will see better ways to establish communication between pods in a while. For now, it's important to understand how the internal networking works in Kubernetes. So it's all easy and simple to understand when it comes to networking on a single node, but how does it work when you have multiple nodes in your cluster? In this case, we have two nodes running Kubernetes and they have IP addresses 192.168.1.2 and 1.3 assigned to them. Note that they are not part of the cluster yet. Each of them has a single pod deployed. As discussed in the previous slide, these pods are attached to an internal network and they have their own IP addresses assigned. However, if you look at the internal network addresses, you can see that they are the same. The two networks have an address 10.244.0.0 and the pods deployed have the same address too. This is not going to work well when the nodes are part of the same cluster. The pods have the same IP addresses assigned to them and that will lead to IP conflicts in the network. Now that's one problem. When a Kubernetes cluster is set up, Kubernetes does not automatically set up any kind of networking to handle these issues. As a matter of fact, Kubernetes expects us to set up networking to meet certain fundamental requirements. Some of these are that all the containers or pods in a Kubernetes cluster must be able to communicate with one another without having to configure NAT. All nodes must be able to communicate with containers and all containers must be able to communicate with the nodes in the cluster. Kubernetes expects us to set up a networking solution that meets these criteria. Fortunately, we don't have to set it up all on our own as there are multiple pre-built solutions available. Some of them are the Cisco ACI networks, Cilium, Big Cloud Fabric, Flannel, VMware NSXT, and Calico. Depending on the platform you're deploying your Kubernetes cluster on, you may use one of these solutions. For example, if you were setting up a Kubernetes cluster from scratch on your own systems, you may use any of the solutions like Calico or Flannel, etc. If you were deploying on a VMware environment, NSXT may be a good option. If you look at the Play with K8's labs, they use WeaveNet as their networking solution. In our demos in the course, we will be using Flannel. Depending on your environment and after evaluating the pros and cons of each of these, you may choose the right networking solution. If you go back and look at the demo where we set up a Kubernetes cluster initially using the kubeadmin tool, we set up networking based on Flannel. It only took us a few set of commands to get it set up, so it's pretty easy. So back to our cluster with the custom networking, either Flannel or Calico setup, it now manages the networks and IPs in my nodes and assigns a different network address for each network in the node. This creates a virtual network of all pods and nodes where they are all assigned a unique IP address. And by using simple routing techniques, the cluster networking enables communication between the different pods or nodes to meet the networking requirements of Kubernetes. Thus, all the pods now can communicate to each other using the assigned IP address. That's it for this lecture. We will now head over to a demo, and I will see you in the next lecture.